All right, welcome to the coding session on temperature forecasting and recurrent neural networks. We will actually do this exercise on a data set from the Max Planck Institute, and we're going to go to Kaggle in order to find that data set. So here we have Kaggle, so I do a search on Jena climate and see where we get. Here it is, Jena climate 2009-2016. And is it what we're looking for? Yes. Here are the weather features, and there's 14 of them. You can see here below all the values of the file. And yes, we have 15 columns. So let's download this file. All right, so now I've downloaded the Jena file, and it's actually on my desktop now. So now I can import it into my Google Drive. Look for the file. Here it is. So let's select the file and wait for the download. Should go pretty fast. Done. All right, so I'm into Colab now. Let's start a new file. Let's call it GRU Max Planck weather. All right, and you know that we have a file on our G drive, so I will need to actually mount Google Drive for this exercise, and I just click on this one here, and there it is already. So let me mount the drive. Here we are. We know the drill here. Easy. Allow. Copy the code and just paste it here. This should take, oh, what's that? Mount failed. Let's try again. Something went wrong here, so let's redo this. Allow. Here we go. Copy. Paste. All right, now it works. Done. The next thing we do is to import the necessary libraries here, which is also obvious. And as you see, I imported pandas. Yeah, that is where this code will be slightly different compared to the one from Francois Chollet's book. Okay, so now I pasted this block of code. It's very easy. We're gonna read the CSV file and create a data frame. And then we're gonna look at the first 5 rows of this data frame. So let me look first where this Jena file is. Here we are, here it is. So I'm gonna right click here, I do copy path, and I paste the path in here. Let me do paste. All right, and now it will show me the first 5 lines of that file. Here we are, and that's exactly what we expected. Yeah, something you could see immediately here is that there's a lot of difference in terms of scale. Yeah, this is here nearly 1000. This is -8. Yeah, so it makes sense to normalize the data to make sure that our mean is 0 and our standard deviation is 1. All right, so let me look at the shape of this data frame, the F shape. So that's exactly what we expect, 420,551 lines, and we have 15 columns, yeah, excluding the index. Yeah, so apart from daytime and the index, we have 14 weather features. All right, so let's now see how we can plot this, and we use a very simple line of code here that allows us to plot columns of the data frame. So on the x-axis we have our samples. I'm only gonna take samples from 415,000 to 420,000. That's about 5,551 data points. And I will set the y-axis the temperature. Yeah, it's exactly as we see here in the data frame. So let's run this. Here we are. You see that there is fluctuations in temperature. You almost go as low as -10, and the high is roughly around 12, 13 degrees. All right, there's something else here. I don't like this date time column because it's not a number and it will be difficult to work with. We don't actually need that as the sequence is given by the index here. So we can drop that column from the data frame, and that's an easy execution. It's one line of code. So from the data frame, we're gonna drop the date time. On axis is 1, that means column. Yeah, so we're gonna delete that column. So let's run this, and now we can do a df shape, and we should see that there's only 14 columns now. Yeah, like before we had 15. So it shows that we have deleted that column. All right, so now we're ready to standardize the data. As you see here, the range of the information is quite different. So we want to scale, and we're gonna use standard scaler, something that we also used in our very first coding session on the K-neighbors applied on the Pima Indians dataset. So here I'm just importing standard scaler, and I call the new data frame the scaled data frame. And basically what I'm gonna do is I'm gonna fit transform that data, and basically what it will do is it will subtract the mean and divide by the standard deviation. But here this line of code allows us to immediately execute this for all the columns of the data frame. So let's run this piece of code, and let's see df head. So here it is. All right. So oh no, sorry, that's not the right one. It's df scaled head. Yeah. Here we go. Do we now have what we want? Yes, exactly. Yeah, you see that all these are normalized now. And now let's call df again, df scaled. So we continue with df. All right, so now we're gonna convert the data frame to a NumPy array. As you know, we're gonna use TensorFlow, and we need to convert all the information into tensors. So let me just make a quick look at df head now. First 5 lines of the data frame. Yeah, it's exactly what we expected. So this one I can delete. And now we're gonna convert this into a NumPy array. Also one line of code. We call the data float data. And float data is basically our normalized data. And we have 14 columns, and these 14 columns are the weather features. And this is what I'm gonna do to convert this to NumPy. So df.toNumPy. And that is very easy. So let me now try to see what elements I have. So here I would say float data 0 is what? Float data here, so I need to run this first and then run this cell, and that's exactly float data 0. This is the first row, yeah, and it's exactly what we see here, right?